Alright, so we're at lesson 2.10 and we're looking at number systems. What are number systems? Number systems are things like, well, what are rational numbers, irrational numbers, and complex numbers, whole numbers, counted numbers, all that kind of stuff. They make up different number systems. So let's go ahead and get started with the warm up. So the warm up for today, it says directions: graph the following equations and then answer the questions being asked for each question. Okay, so if I look below, the first question that I see in this little box that's kind of highlighted, it says given h of x is equal to negative 1/2 x squared plus 5, it wants me to list the axes of symmetry, the vertex, the x-intercepts, and the y-intercepts. So I'm going to use Desmos. I'm going to go over to Desmos, and I'm going to just plug the equation into Desmos, and I'm going to say y equals negative 1/2 x squared. Oh, and I think that's wrong. Let me use let me backspace that. Okay, so negative 1/2 x squared plus 5. Okay, make it a little bit faster. Okay, so I see here my vertex is at 0, 5. So over here, I'm going to come in and write my vertex is at 0.05. So since this is my vertex, I know that my axis of symmetry is that line that goes directly through that vertex. And it's a vertical line, so it's going to be x equals 5. And my x-intercepts is, look, I have 2 of them. And so I'm just going to write, there it crosses the x-axis at negative 3.16 and also positive 3.16 for my x-intercepts. And then my y-intercept, I can see that it crosses the y-axis here at 0.5, so I'm just going to say it crosses the y-axis at 5. Alright, now let's look at the other one here, and I'm going to take this one out, put the other one in. So the other one is open parentheses, or let me say that, f of x equals, open parentheses, we have x plus 4, and I see that I'm squaring that entire thing, and then plus 3 at the end. And so quite naturally, I can see my vertex very easily, which is at negative 4 and 3. So negative 4 comma 3 is my vertex. My axis of symmetry is going to be this line. If you notice, it's always the x coordinate of your vertex. So x is equal to negative 4. And if you graph that line, I'm going to come over here, and if I say x equals negative 4, you can see it splits a vertical line. That's your axis of symmetry, but I wanted you to be able to see that. And I have no x-intercepts because it doesn't cross the x-axis at all. And my y-intercept, it looks like it's trying to hide from me a little bit there. So let me see if I can like kind of scroll up or zoom out. And I see that my y-intercept is at 19. So it crosses the y-axis at 19. Alright. And then we said, it says describe the transformation from the parent function g of x is equal to x squared to, okay, so I have 2 different functions here. So I'm just going to plug them both in and just see if I can see a difference. So I'm going to say y equals, instead of saying g of x, but we know they mean the same thing. Okay, y equals 2, or y equals x to the second power. And then the other one is y equals 7, open parentheses, x minus 2, close parentheses. We're going to square that, and then minus 5 on the outside. Alright, so as you can see, they want me to describe the transformations from the purple function, which was the first function that we put in, to the second function. So automatically, I can look and I see that if I'm just observing the vertex points, I can see that this caused it to shift to the right too, and it also caused it to shift to down 5 units. So over here, I automatically see that I had a shift left or shift right. I'm going to say shift right. Five, right? Is that right? No, shift right 2. And then it also shift down. Five. And what else occurred? It got narrow. Okay, it also got a little narrow. All right, now what I'm going to do is I'm going to draw something over here to kind of connect this to the equation. So what caused it? Where in the equation do you see where it shifted, caused it to shift right? That's right, that 2 inside there caused it to shift right. And what caused it to shift down? This -5 that's over here. And then quite naturally, what made it more narrow? And this 7 right here caused it to be a little bit more narrow. Okay, so what do you think would happen if I place other values there? What kind of effect do you think it would have on it? That's just something to think about. All right, so today we're going to jump in and we're going to look at different number systems. And so first of all, before we take a look at them, I want to just jog your memory a little bit and see if you remember what counting numbers are. Okay, this kind of started where we derived all these different types of numbers from. So we're going to look at it from a number line standpoint. So counting numbers, and I'm going to make my little arrowheads there so I know it's a true number line, and hopefully you guys are doing the same. So when we started out with this whole number system idea, we started out with counting numbers. And so counting numbers started with 1, 2, 3, 4, 5, 6, okay, and then it kind of went on, okay, and as you can see, all these numbers are positive and they're whole numbers. Well, then we got into, well, whole numbers. Well, what's the difference between counting numbers or natural numbers and whole numbers? Well, when I want to talk about now 0 having nothing, then I introduce whole numbers, and so then it's 1, 2, 3, and so forth and so on. But as you can see, at this point, I still have no idea what integers are. And so when integers came into play, we had 0, and then we started introducing negative numbers into our vocabulary. So these are negative whole numbers. So we call those integers. So integers are made up of positive and negative whole numbers. Okay, and let me put my arrowheads on there so I can make an official number line there. Okay, and then we have what we call rational numbers, and rational numbers are numbers that can be written as a fraction. So I'm going to put 0, 1, 2, so I'm going to call this -2, -1, and I'm going to call this +1 and +2. So then we had to introduce, well, what happens if I don't have a whole dollar, or if I don't have a whole $2? You know, then you start to get into fractions of numbers. Okay, that's where you got like 1/2, okay, would be what we consider to be a rational number, or 3/4 would be considered a rational number, okay, but 3/4 would be somewhere in there because it's not quite a whole yet. And then if we have 4/4, of course, that would be a whole. Okay, so then we have rational numbers. So rational numbers include all my whole numbers, all my counting numbers, all my integers are what's inside of rational numbers. And then lastly, we have what we call irrational numbers. And irrational numbers, well, these are numbers that just can't be expressed as a fraction. Okay, so we have 0, let's say -1 and -2, and we have 1, and we also have 2 here. So then, of course, you got your little half numbers here. But what about numbers that I can't write as a fraction? You know, and these are numbers that where the decimal number doesn't repeat. Say, for instance, like the number pi. Okay, and I know you guys are all familiar with that, but it's 3.14. No, I wrote that wrong. I said 314. But it's actually, let me write that back. So pi is equivalent to 3.14. That's normally how you, but it's a decimal number that doesn't really repeat itself, and so therefore it can't be written as a fraction. So this is what we call irrational number. And so quite naturally, you know that if I were to express pi on a number line, it'll probably fall somewhere between, like, this would be 3 and this would be 4. So it would fall somewhere in between here. Just not quite sure where, maybe a little bit closer to 3 just because it's a 3.1, but it falls somewhere in between the whole number 3 and 4, but we cannot express it as a fraction. So we call those numbers that can't be written as a fraction, we call them irrational numbers, okay, and which we'll talk about some more. Then we know that all these numbers that we talked about, first we started off with natural numbers, then we got into whole numbers, then we can talk about integers and rational numbers, and then we have some irrational numbers over here. And as you guys see, you have some examples there. Today, we're going to get into talking about complex numbers. Well, what are complex numbers? Okay, it's a different number system that doesn't really fit into the number system that we're used to counting with, like talking about negative numbers and fractions and things like that. So it's kind of like a number system that kind of sits out on its own. So when we talk about complex numbers, well, as you can see, complex numbers are made up of a real number plus an imaginary number. And so this symbol here, which is a little I, it's like a little italicized I, it represents imaginary numbers, okay? And so the imaginary number I is just equivalent to the square root of -1, okay? I is the same thing as saying -1. So if I write I, I'm just writing the square root of -1. Okay, could I replace writing I with the square root of -1? Yes, I could, because they're equivalent. They mean the same exact thing. Okay, so I want to kind of show you guys something. So just piquing my curiosity, I want to put the square root of -1 in my calculator, and I want to show you guys that you're going to get an error all the time. And if you read that error, it says in real mode, all calculations must result in real numbers, telling us that, hey, the square root of this negative number is not a real number. So I'm just going to hit enter to quit that. All right, so I'm like, okay, I got this error here. So that's funny business right here. All right, so how do we work with this I? Well, let's look at it. Okay, and we treat this I like it's a variable because it is a variable, but the good thing about this variable is that it has values, okay? It has values as we just shown, and so first of all, we know that just I to the first power, or I, is the same thing as saying the square root of -1. Well, what happens if I square I? Okay, that's meaning like raise I to the second power. So if you raise I to the second power, basically saying like take I, which is the square root of -1, and I raise it to the second power, is basically taking the radical off of that and just producing a -1. Okay, so I squared is equivalent to just -1. Okay, well, what is I to the third power? Well, I know what I I know what just I is equivalent to, okay? And I'm writing these little i's like this. So I know what I is equivalent to, and I know what I squared is equivalent to. Now, if I add those together, it will still give me I to the third power. So I'm using this because I already know the values of the previous one. So instead of writing I, or I'm just going to keep I, okay? And I know that the value of I squared is -1. So instead of writing I squared, I can just write -1. So I get -1 times I, which is equivalent to -I. So the value of I to the third power is just equivalent to -I. Well, what about I to the fourth power? Well, I'm going to use I squared times I squared. Okay, so I squared times I squared, well, it's like saying -1 times -1. All right, and very easily, I know that a negative times a negative is going to give me a positive, so -1 times -1 is 1. Okay, so what if I told you that I to the fifth power is just I, and what if I told you that I to the sixth power is just -1, and what if I told you that I to the seventh power is -I, and I to the eighth power is 1? You would probably say, oh, Miss Ross, I see a little pattern that's going on. And I would say, hey, you're absolutely right. So these values of I, they go into a little cycle, okay, where they just keep repeating over and over and over again, and they go in fours, okay? They go in fours. We start at I, and it keeps repeating based off of how you increase it. But let's take a look at some examples so you can see exactly what I'm talking about. All right, let's not go backwards. Let's go forward. All right, so I to the 10th power. Well, I know that I to the 8th power, let's go back and look at that. I to the 8th power was 1. So I to the 7th power would be I to the 8th power would be -1. So, I mean, I to the 10th power would be -1, right? If I were to keep going in this cycle, so I know that I to the 10th power would just be equivalent to -1. Now, but the thing is, what happens when these numbers get a little bit big or a little bit bigger? I have to think about it. Well, I'm going in cycles of 4. So every fourth, it starts to repeat itself. So we're going to use the remainders, okay? And I'm going to show you what I mean. So since 4 is a cycle, if I divide these numbers, okay, the exponents by 4, it'll help me to figure out the cycle that I'm going in. Remember, we got I squared is equal to -1. Then we have I to the third power is equal to -I. And then you got I to the fourth power. I to the fourth power is just equal to +1. And then after that, it starts to repeat itself. So let's take 25 and we're going to divide it by 4. Okay, and I use 25 because this is my exponent here. So, because I'm working with these exponents trying to find the value of these i's. Okay, so I get 6. So I see that 4 can go into 25 6 whole times. So that means I can go through and get 6 whole cycles. So I'm going to do 6 times 4, and it gives me 24. So therefore, I have a remainder of 1. Now let me show you what I'm talking about. Hopefully that, you guys will pick up. So I'm going to take 4 and I'm going to divide it. We're going to go back to elementary and do some long division. So I see that 4 can go into 25 6 full times. So that means I get to do 6 full cycles. Then you multiply and you get 24 here. So you have a remainder of 1. So that means that you're going to use I to the first power as is equivalent to I to the 25th power. Okay, using this remainder right here. This is the exponent that we're using. So I to the first power is just, or I to the 25th power is just going to be I. Okay, so we do the same thing with the 100. We take 100 and we divide that by 4. Okay, so how many times can 4 go into 100? 25 times, right? So if you didn't know that, you can just divide it. So 100 divided by 4, you get 25. So 25 times 4 is 100. So this time I don't have a remainder. So since you don't have a remainder, then that means it went through it that many cycles, okay? 4 or 25 full cycles with no extra cycles left over. So therefore, I to the 100 power is just equivalent to just 1. All right, so what about 121? Same thing, 4 divided by 121. Well, how many times can 4 go into 121? 121 divided by 4 gives me 30. So it goes in there 30 full times. So 30. All right, so now I'm going to multiply 30 by 4, and I get 120. So what is my remainder? My remainder is 1. Okay, so since my remainder is 1, I use whatever I to the first power is, and in this case is just I. So in this case, I to the 121st power is equivalent to just I. Okay. All right. So let's move on. So now that we worked some numbers with the I's, now let's think about this from a different point of view or different perspective. So when do I encounter complex numbers? Okay. Now before, and I just showed you guys how to work with the imaginary number I a little bit because it has values, but complex numbers are made up of real number plus an imaginary number. Okay, now what does that look like? So, question. We're going to simplify the square root of negative 25. So, you should already know how to simplify radicals, but you don't really know how to simplify negative radicals. If I come over here and I do the square root of negative 25, well, you're going to get an error because we've already know that we can't take the square root of negative numbers. So how do we handle this situation? All right, just like this. This is how you handle it. Now, in order to get rid of this negative under here, it is going to turn into an I. And let me show you what I'm talking about. So this is like saying the square root of negative 1 times 25. Because if you multiply them together, you're going to get negative 25. But if you notice that now you kind of can do the square root of 25 because it's positive, and you know that the square root of negative 1, and I'm going to come over here and write that to the side, the square root of negative 1 is just equivalent to I. So therefore, you can rewrite this as now the square root of 25 the square root, so this is equivalent to the square root of 25, and then because this is negative 1, you can pull out that negative 1 from under the square root, but when you pull that negative 1 out, it has to come out as an I because it's an imaginary number. Okay, so we put the I on the outside of the radical. So now we have the square root of 25, and there's an I out there, and if I simplify this, this would just be 5 times I. Okay, because the I is already out there, and then you simplify the square root of 25, you should get 5. You multiply them together, and you get 5I. Now, the question is, okay, knowing that I get 5I, I'm looking for what is my real number and what is my imaginary number. Some of you guys might want to say the real number is 5 and the imaginary number is I, but that's not the case, because if I is attached to a number, then that would be considered the imaginary part. Anything that is attached to the I is called imaginary. Okay, so in this case, I don't have a real number part, so I'm just going to put 0. So this is like saying 0 plus 5i, because the real number part doesn't exist. There's nothing. All right, let's take a look at another example here. So now this time I have negative times the square root of negative 25. So again, I'm going to take the I out, okay? Now, there's already a negative outside of that square root, so don't get that confused, okay? Since there's a negative out there, you treat that negative as if it's a negative 1. And so negative times the square root of negative 1 times 25 still, okay? Now, you can move that negative 1 out, okay, by pulling an I out, letting me know that it's imaginary. And so this will now be negative I on the outside times the square root of 25. And so when you simplify the square root of 25 now, you should just get negative 5i, okay? All right, now what is the real part and what is the imaginary part? Well, again, we have no real part, and our imaginary part is negative 5i. Okay, let's look at another example here. All right, so here I have 1 plus the square root of negative 28. Well, I can't add the 1 and the 28 together because the 1 is just the number, like by itself, a whole number, and the square root of 28, well, it's a complex number if you haven't noticed, but let's work with it. So I'm just going to write the 1 and plus. Now, the 28 can be rewritten as negative 1 times 28, or the square root of negative 1 times 28. I get rid of that negative 1 by pulling the I out. Okay, when you pull the I out, now you're left with 1 plus I times the square root of 28. Now all you have to do is simplify the square root of 28. When you simplify the square root of 28, you should get 1 plus, you break that down. So that should be 4 times 7. The square root of 4 is going to be 2. So it should be 2i times the square root of 7 when you simplify that. Now, this whole thing right here, this whole term is my imaginary part because it has a I connected to it. So my imaginary part would be 2i times the square root of 7. My real part would just be the positive 1. And so this time you can see quite naturally that this 1 is written and it does not have an I that's attached to it at all. All right, let's look at another example here. Okay, so here we have same thing. So we got to simplify all of this. This 36, or the square root of 36, has a negative under it, but we both know that you can rewrite that as the square root of negative 1 times 36. Let me write that better. So negative 1 times 36 under this one, and then the square root of 25 is just fine, okay? We can simplify that perfect, and hopefully you guys notice that these are perfect squares, but when you see this negative under the square root, you can pull out an I, okay? So I'm going to bring this all over here. So I have I times the square root of 36 now, plus the square root of 25, okay? Now I can simplify the square root because the negative is gone. So the square root of 36 is just 6. So therefore, this comes to just 6i, okay? And then plus the square root of 25 should just be 5. So now this is what you have, okay? Now, as you notice, I want my real part to be first and then my imaginary part. So I'm just going to flip them around so that I'm going to put 5, a positive 5 because it's positive, plus 6i, because the 6i is also positive. So all I did was make sure that I wrote my real part first and then my imaginary part second. So my real number would be 5 because there's no I attached to it, and my imaginary number would be 6i. Okay, hopefully this is getting a little bit easy now. All right, so here at the bottom, I have the square root of negative 25 divided by 5. Well, look, I'm dividing. All right, and some of you guys might say, oh, I got to pull the I out. And you could, but remember that you're dividing these things, so I could go ahead and just divide these. And if I were to divide these numbers, I would get, well, 25. Let's put that in a calculator. So negative 25 divided by negative 5. That's going to give me just 5. So now, what's left under the square root? Just 5. Can you simplify this anymore? Absolutely not. Okay, so therefore, this is not a complex number. Okay, it's not a complex number. Not a complex number. Okay, because it doesn't have an I attached to it. So therefore, it doesn't have an imaginary part, but it do have a real part, and the real part is the square root of 5. Okay, all right. So now what I would like for you guys to do is to try some on your own, and then we'll come back and we'll take a look at these.